This project is called Dancing Raisins, and for it you need a glass filled with clear soda and a few raisins. Objects with a density greater than that of the liquid they're submerged in sink. This is why the raisins sink in the soda at first. The carbonated drink releases bubbles of carbon dioxide. The bubbles stick to the rough surface of the raisin and increase its buoyancy, causing the raisins to float. When the raisin reaches the surface, the bubbles pop and the carbon dioxide gas escapes into the air. This causes the raisin to lose buoyancy and sink back down. The raisins continue to rise and sink until the soda goes flat and loses the carbon dioxide bubbles. Buoyancy is the upward force exerted on an object submerged in liquid. The buoyant force is equal to the weight of the fluid that is displaced by the submerged object. The amount of liquid displaced does not depend on the weight of the object, but its volume. In the case of the raisins, when the carbon dioxide bubbles attach to them, their volume increases. The increase in volume causes the raisin's density to decrease. When an object is less dense than the liquid it's submerged in, it floats. The increase in volume increases the amount of fluid displaced, which in turn increases the amount of buoyant force that is acting upon the raisin. When the carbon dioxide bubbles pop at the surface, the volume of the raisin decreases and its density increases. Since buoyancy depends on volume and not weight, the decrease in volume decreases the buoyancy to the point where it can no longer hold up the mass of the raisin, and the raisin begins to sink. This process continues until the soda is no longer able to produce the bubbles of carbon dioxide.